They are similar in that their velocities are both directly proportional to their frequencies and wavelengths, as shown by the equation velocity equals frequency times wavelength. In both cases, they transfer energy without the transfer of matter. Both types of waves can also transition through different mediums. Electromagnetic waves can reflect like mechanical waves. They can also refract when changing mediums like mechanical waves. Finally, they both diffract, or bend around obstacles. They are different because electromagnetic waves can travel in a vacuum and mechanical waves cannot. Mechanical waves require a medium. Electromagnetic waves are also caused specifically by the vibration of charged particles. Mechanical waves travel much slower than electromagnetic waves. Mechanical waves travel faster in solids than gases, but electromagnetic waves travel slower in solids than gases. Finally, electromagnetic waves are only transverse, whereas mechanical waves can be transverse or longitudinal. Visible light is the only portion of the electromagnetic spectrum which our eyes can detect. It is approximately in the middle of the spectrum, surrounded by UV rays, X-rays, and gamma rays, which have higher frequencies and smaller wavelengths, and radio waves, microwaves, and infrared waves, which have lower frequencies and larger wavelengths. Radio waves are electromagnetic waves. They travel at the same speed as light and have frequencies that range from 30 GHz to 3 kHz. Their wavelengths range from 1 mm to 100 km. They are used to transfer information long distances and are especially useful because they can be used to communicate information into space. Seismic waves are mechanical waves. Common causes of seismic waves are the breaking of rocks in the Earth's crust, volcanic eruptions, or explosions. Their velocity is impacted by the density and elasticity of the medium. Their velocities tend to increase with depth because the increased pressure causes greater density and elasticity. Discoveries by the scientist named Planck explain why higher frequencies are more dangerous. He noticed in his black body research that hot bodies glow brighter than cool ones. Research based on this observation led him to conclude that energy equals frequency times Planck's constant. Therefore, the higher the frequency, the more energy the wave has. If the wave has enough energy, it can actually cause an atom to ionize. The energy in the wave essentially knocks an electron out of the electron cloud of the atom it passes by, causing it to become charged. This is called ionizing radiation. It can be very harmful to the human body because it destroys the cells. That is why higher frequencies are more damaging.